Hello and welcome everyone. I am Olunlade Joshua, and today we are going to be understanding what a button is. Before I move on in this tutorial, let me quickly say that this tutorial is supposed to be taken by my colleague Ojo Emmanuel, as he prepared most of the tutorial content for this particular video. However, something very important came up and I just had to step in for him. That said, now let us go into what a button is. A button. A button is simply a switch which makes or breaks a circuit. So I want you to look at it like this. A button is a device where it can join two wires together or break two wires. Just look at it like that. I will show you how it looks like in the next slide. There are various kinds of buttons. However, the button we'll be using for this course is in such a way that when pressed, the button will make the circuit. That is, it will connect both ends, both of its leads together, and when it is released, the button will break the circuit. This is how the button we'll be using for this course looks like. Now let us see its configuration. Okay, this is a button, and before I explain how a button is configured, let me quickly show you this illustration. Look at these two wires, these two jumper wires. If I wanted to connect them together, once I connect the ends like this, let me join it together. Once I join the ends together like this and it is in contact, these two wires are now electrically connected. Is that right? Yes. And when I break it, that's when I separate it, something like this, then the two wires are no more electrically connected. Yes, that is exactly what a button does. So now a button, this is how the button in your kit looks like. Let me just zoom in on that a little. Okay, this is how the button in your kit looks like. I hope that you now know how the breadboard is connected. On this breadboard, let me just quickly divert and explain that again. Let me use look at it. From A1 to E1 are electrically connected together. From A2 to E2, they are electrically connected together, but line 1 and 2 are not electrically connected together. There is a bridge here that disconnects the electrical connection. So this line and this line are not electrically connected together. However, from J1 to F1 are electrically connected together. So just a quick recap of how to use the breadboard. Now that said, that means that this is A17 now. So from A17 to E17, which is under the button somewhere here, to E17, they are electrically connected together. So that means when I connect anything here, it will be connected with this lead. Let me raise it a bit. Okay, to be connected with this lead of the button. You can see that I have inserted my button into the breadboard, so it will be connected with this lead of the button. So if I connect a jumper wire here, it is connected with that lead of the button. And if I connect my jumper wire here on line 15, it is connected with that lead of the button. So that said, now you will see that the button has four legs or four leads, 1, 2, 3, 4. And how are they connected together? Okay, let me remove this button and I want you to look at this. Okay, look at the way it is. You can see that the leads are bent in a certain way. They are bent something like this. Let me zoom out so that you can see my illustration better. The leads are bent kind of like this. So this is how you put in your button to your breadboard, like this. It is not like this. You can see that it won't even enter this way. Let me show you. It is not like this, like you put in your button, but like this. And remember that any component that you put into your breadboard should be firmly secured. Okay, that said, now how are these leads of the button connected together? Okay, well, it is actually simple. You know, like in the breadboard where we said that this and this are electrically connected together. We said that this A12 and E12 are electrically connected together. Something like that works for the button too, but let me show you what I mean. You see this lead of the button, this one, sorry, okay, this one on this side, this first lead of the button on line 15 is connected electrically inside the button to this other lead of the button. So both are connected. So basically the button has connected everything in line 15 across this bridge. Is that clear? Okay, this lead of the button, the second one, the one in line 17 here, is connected electrically across this button to this other lead. So that means that if I connect a wire here, a jumper wire here, and if I connect a jumper wire here, because the button is here and the way it is connected, oh sorry, you can't see that well. Okay, because the button is here and the way it is connected is that this lead here is connected to this lead, that means that both of these jumper wires are connected together. Okay, that said, now there is no connection between this side of the button and this side. So that means that the connection of the button breaks across it like this. So there is no connection between line 15 and line 17 yet. There is no connection. So let me plug in a jumper wire now. So when I plug in a jumper wire to line 17 and I plug in another jumper wire to line 15, there is no connection between this jumper wire, the white jumper wire, and the green jumper wire. But that is where a button is nice. When I press this, when I press the button, when I press it and I hold it, it connects both. It connects all the legs of the button together electrically inside it. So that means that both of these jumper wires are now connected. Let me explain again. When I press the button like this, I'm pressing the button now, it connects all the legs of the button together electrically. That means that both of these jumper wires are now connected together with the way I have connected them. Okay, now that said, let me use an Arduino for 5 volts so that you can see what I'm saying. Okay, let me zoom out a bit. So I have quickly connected an LED here, and I did not do anything special really. All I did was to connect the LED in such a way that it is connected to 5 volts. You can see that, like in our former videos, I have connected the LED with a resistor, but instead of connecting it to a digital pin now, I have connected it directly to 5 volts. So when I power my Arduino now, let me plug in my power cable or my USB cable. When I power my Arduino, the LED comes on, and I just want to show you something very important here. When I power my Arduino, the LED comes on. Okay, now let me zoom in on the LED on the breadboard. Okay, when I power my Arduino, the LED comes on. So what I want to do is to control the button, the LED with the button. And although it may look a little confusing in the next lesson, it isn't. What I want to show you here is how the button makes and breaks circuit. So this is the wire that connects the anode to 5 volts. So I'm going to remove it now, and you can see that the LED has gone off. Is that correct? Yes. So I'll plug this wire to one of the leads of the button, the one on line 17. Then I would bring in another jumper wire. Let me use a purple jumper wire, and I will connect it to this lead. I'll connect it to this lead, and then connect that lead, the second end of the jumper wire, I'll connect it to the 5 volt rail. Okay, as you can see that the LED is not on. However, we said that anytime the button is pressed, what happens? All the leads of the button, so the 4 legs of the button, they are electrically connected together inside the button, which means that this purple wire and this yellow wire will be electrically connected together, and that means that 5 volts will flow through to the anode of our LED and make it come on. So this is a direct button connection. Look at it. You can see that it comes on and then off, on and then off, on and then off. Okay, now that said, let me quickly mention something in this video before we end this video. When you are connecting a button to a digital pin, this is the Arduino. Now we are not going to program it in this video because I have not even introduced what a button is, and I've not even introduced how you can program a button with the Arduino. But I just want to quickly mention this because I may not mention it in the next video. When you are working with a button, like when you want to read in digital input from it, let me connect it to pin 2 now. That is connected to pin 2. So when you want to read digital input from a button, you have to connect a resistor to it. Okay, let me come again. When you are reading in digital input from a button with the Arduino, I want you to note it. Maybe you should actually write it down somewhere. When you are reading in digital input from the Arduino, okay, let me quickly explain this. A button is a digital signal which can be 1 or 0. So when I press this, it will connect this purple wire and this yellow wire together. What we are reading on the pin of the Arduino is basically voltage. So when we say digital read, what we want to read is, what the Arduino is reading is this pin at 0 volts, that is it low, or is this pin at 5 volts, or is it high? So when we connect 5 volts, you can see that this purple wire connects to the 5 volt rail. When we connect it to one end of the button, we have connected that end of the button to 5 volts. And when we connect the other end of the other jumper wire, the yellow jumper wire, to our digital pin 2, we have connected that side of the button to pin 2. That means that when we press this button, it allows a 5-volt voltage to flow into the yellow wire and back into our digital pin 2. That means that the voltage level on that digital pin 2 will be 5 volts. Do you understand? Will be 5 volts. So when we tell our Arduino to read in what the value, or when we tell it to perform a digital read on that pin 2, if the button is pressed, 5 volts will be flowing through the wires and back into pin 2. So it will read in a digital state of 1. However, if it is not pressed, then nothing is flowing through it. That means it will read the digital state of 0. But this is not always the case. That is why we add a resistor to bring down the level of the voltage. Okay, just go down. You will understand it. And I want you to read a little about it online or something. Okay, this is a button, right? You have connected one end to 5 volts and you have connected the other end to a digital pin. So you are expecting that whenever this button is not pressed, this digital pin, the lead here, should be at a state of 0 volts. However, this is not always the case because of electrical noise and some other signals that will affect your button. So we usually connect this lead of the button. You know, this is electrically connected together with this side. So the whole of line 17 now is electrically connected together. So we usually connect the line or the part of the button that is also connected to the digital pin. We usually connect it with a resistor to ground. Usually I call it bringing down that button or that pin to ground. So we connect it to ground, something like this. You can see that I have connected it to ground. You can see that I have connected that resistor to ground. Okay, I have connected it like that, and this is a 10k ohms resistor. Anything 1k or 10k will do. So this resistor, what it does is that it makes sure that anytime this button is not pressed, let me bring in a jump wire. It makes sure that anytime this button is not pressed, that this line, the line connected to the digital pin 2, will always remain at a point of 0 volts. Will always remain at a point of 0 volts. However, when you press it, the resistance is not enough to connect ground and 5 volt directly together, which will be short circuiting. So which will connect 5 volt to the digital pin, and you will get a 5 volt logic level on that pin. I hope it is clear. This configuration works for when you are connecting it to a digital pin. Okay, let me quickly mention that a button is a digital input, and what that means is that it can either be high or low. That is, it can only be 1 or 0. You see, when the Arduino sees that there is a 5 volt on the digital pin that you have connected your button to, it will read in a state of 1. However, if it sees that there is a 0 volt on it, it will read in a state of 0. So a button can only be high or low. That makes it a digital input. We will still explain what digital and analog pin inputs are in the future, but for now this will do. Thank you for watching this video. If you have any questions, or curiosities about what we have done today, please ask on the JILBOTIcs Classroom platform. I am Olunlade Joshua, and bye for now.